Thank you, Felix and Jaime. I'm Florian Shkurti, and I'm an assistant professor in computer science at the University of Toronto.
And I'm Matt Gamma, a PhD student at the University of Toronto as well.
In previous years, this workshop has featured debates concerned with the structure, costs, and benefits of large robotics conferences such as ICRA and IROS. Debate participants articulated frustrations with the status quo that many of us share, while also distilling the practices and experiences that make attending conferences so worthwhile for all of us.
The conference experience is clearly a major touchstone for the robotics community, but this year we're shifting our attention to individuals, students, engineers, junior and senior faculty, all the people that constitute our ever-growing multidisciplinary field. More specifically, our first debate considers the following resolution. Let it be resolved that individual success metrics prevalent in robotics create perverse incentives that harm the long-term needs of the field. And before we begin our debate on this topic, Florian's going to talk about it a little more, but please go to Slido and vote on whether you agree with the resolution as stated.
Our field has been experiencing rapid growth in demand for participation across all ranks, from undergraduate students who are trying to gain experience and enter the discipline, to young graduate students who are trying to carve their own research trajectories, to faculty members who are given the privilege and responsibility of setting long-term research agendas, to robotics engineers and entrepreneurs in industry trying to build products that work robustly and maximize profit. On the supply side, we have groups and individual decision makers with limited resources, such as faculty and supervisors with limited time for mentorship, hiring committees selecting candidates for only a few available jobs, and limited investments from government and industrial funding institutions. With availability of resources typically lagging the demand, we have come up with various metrics to assess the level of success of individuals based on their number of publications, the citations and awards that they received, or how widely their products were adopted, and other such factors that often lead to hyperproductivity or the superficial appearance thereof, while increasing barriers to entry. Often lost in this complex discussion of personal career advancement is the question of whether the long-term needs of the field are actually harmed by the individual incentives that we have collectively set up. Arguing for this proposition, we have Professor Elizabeth Croft, who is the Dean of Faculty of Engineering and Professor of Mechanical, Aerospace and Electrical Engineering at Monash University in Australia. Her research in industrial robotics and human-robot interaction advances the design of intelligent controllers and interaction methods that underpin how people and autonomous collaborative systems can work together in a safe, predictable, and helpful manner. She is the recipient of the Alan Blizzard Award, the R.A. McLachlan Award in Engineering, and was also selected as one of the top 100 most powerful women in Canada in 2014 by WXM. Joining her, we have Professor Stuart Russell from UC Berkeley, who is the holder of the Smith-Zare Chair in Engineering and director of the Center for Human Compatible AI. He is the recipient of the ICRA Computers and Thought Award and the Chair Blaise Pascal in Paris. His book, Artificial Intelligence, a Modern Approach with Peter Norvig, is the standard textbook in AI, used in 1,500 universities in 135 countries. His research covers a wide range of topics with an emphasis on the long-term future of AI and its relation to humanity. He's also currently working to ban lethal autonomous weapons.
Arguing against the resolution, we have Professor David Su of the Department of Computer Science at the National University of Singapore. His research on a variety of topics in robotics and AI includes algorithms for planning under uncertainty in complex environments. He is an IEEE Fellow, has experience chairing multiple major robotics conferences, and his many accolades include the Humanitarian Robotics and Automation Technology Challenge Award at ICRA 2015. Joining him is Professor Matthew Johnson-Roberson of the Department of Naval Architecture and Marine Engineering at the University of Michigan. His work is on the cutting edge of perception for autonomous systems in challenging application domains like self-driving cars and marine robotics. He received the National Science Foundation Career Award in 2015, and he is a co-director of the University of Michigan and Ford Center for Autonomous Vehicles. We're delighted to have David and Matthew defend the various criteria used by schools, companies, and other institutions to measure candidate roboticists' success or suitability for a position. Finally, to make sure things flow smoothly and don't devolve into virtual fisticuffs, Our first debate moderator is Katherine Kuchenbecker, a director at the Max Planck Institute for Intelligent Systems in Stuttgart. She is a leading researcher in haptic interfaces and sensing systems, which enable teleoperated and autonomous systems to make use of the rich sensing capabilities of touch. Her argumentative prowess in last year's debate on the relative costs and benefits of large robotics conferences like ICRA makes it difficult for me to imagine a better moderator for this topic, so I invite her to take the virtual stage and get our first debate started.
Thank you so much, Matt and Florian and all the other organizers for getting us together for this very important practice of debating, of discussing, of considering both sides of an argument, of an important topic to our community. I see we have 28 people on the poll who've completed the poll. Please go ahead and vote now. And I really encourage people to keep an open mind, because I think we're going to learn something today from the wonderful panel of 4 debaters that we have assembled. If I make a mistake as I'm moderating, I apologize. Please just jump in, debaters or organizers, and correct me. I want to make sure we follow the flow in the proper way. And I'm really looking forward to hearing this discussion and seeing not only is it who will win this debate, but also maybe together we can come up with some ideas about that might have an impact on both us as individuals, future people to enter our field, and where our field might be going. Because this debate topic about individual success metrics, I think it touches all of us. It's at this very micro level and broadens out. And I'm really curious to hear our debaters and what they think perverse incentives are, what the long-term needs of our field might be. So with that, we progress into the section called opening arguments. We're going to have each of our 4 debaters present for 5 minutes. We're going to have first Stuart Russell from the For team, and then David Su from the Against team, and then Elizabeth Croft from the For team, and Matthew Johnson-Roberson from the Against. We'll go in that order. I'm going to keep a little timer. Stuart, are you ready to share your opening arguments? And here I'll just read it again. The statement we are debating is individual success metrics prevalent in robotics create perverse incentives that harm the long-term needs of the field. Stuart.
Thank you very much. Thank you to the organizers for bringing us together. First, what are the individual success metrics? Let's start with my least favorite: citation counts, H indices, counts of NeurIPS, or even ICRA papers, and so on. I think these metrics are fine for measuring general levels of activity in different subfields, sometimes even in different countries, for tracking the ebb and flow of topics and fads. Are they good measures of individuals? No, I don't think they are. I don't need to go into great depth on how harmful this metric is. But I would say I've reviewed more than 1,000 appointment and promotion cases at Berkeley across every department in the university, and none of those cases were based on paper counts or citation counts. It may please you to know that amounts of funding are also completely ignored. The question is always, what did you add a real value to human knowledge and understanding? Next, there are benchmarks. Probably the most famous one right now is ImageNet, but they stretch back much further than that, the International Planning Competition, RoboCup, and so on. And I'm sure my distinguished opponents in this debate will point to their value in ensuring comparability across methods, in facilitating the sharing of code or data, for standardized hardware platforms, for reducing startup costs, and promoting quantitative progress in the field. I think it's important to separate standards from competitive benchmarks. The kilogram is a standard and therefore very useful, but it is not a competitive benchmark. And I claim that much of the benefit of benchmarks derives from the creation of standards and not from their use as success metrics. RoboCup, for example, created standards for robot categories, and it was a standardized task. It was fun, it attracted people into robotics, it gave them experience. In the early stages, it pushed the state of the art for tasks such as robust self-positioning and stable walking gaits. Its first incarnation started to lose its value when winning depended on task-specific hacks, like the push-down slap shot or the IBO elbow walk. In the same way, chess as a benchmark lost its value when winning depended more on coding move generators in assembly language or designing special purpose chips. And unfortunately, winning became the only thing. By the 1980s, you could not publish a new idea for a chess algorithm unless you also beat the current world champion program with your algorithm. In other words, benchmarks become a real barrier to research. New ideas cannot be published unless they beat the benchmark. Reviewers also stop trying to understand the key ideas in the paper. They just look at the comparison tables with the bold-faced numbers for the winner. I saw this happen with the international planning competition. In fact, entire subfields of planning, such as hierarchical planning, evaporated because they could not easily be turned into competitive benchmarks. Once a field becomes obsessed with benchmarks, the more original and less incremental the paper, the lower the chance of acceptance. And typically, benchmark problems are not the real problem definition that we care about. In machine learning and in planning, for example, they disallow or minimize the use of prior knowledge because that would make comparison hard. We see this in psychology, where psychologists test humans only on nonsense tasks where they have no idea how to do them. Real learning and real planning take place in the presence of prior knowledge about the domain, and intelligence is a fundamentally cumulative idea. Physical benchmarks are even more of a problem because they are particularly susceptible to over-specialization. One cannot easily have a suite of thousands of physical environments that are exactly copied across multiple institutions. Some of you may remember the Little Dog DARPA program, which involved benchmarks for clambering over rocks. And every month, DARPA had to manufacture and distribute a new set of rocks to the participating institutions. If we look at, for example, the Willow Garage Grand Challenge of laying the table for dinner, it will be no good having one standard table and one standard set of plates and knives and forks. You know exactly what would happen. There would be completely non-robust, non-generalizable solutions optimized for that table and those plates. What we would really need is a generator of kitchens and houses and utensils and carpets and trays, which can probably only be done in a quasi-realistic simulation environment, which comes with its own problems. Another harmful metric that I see a little bit in my brief exposure to robotics meetings is the emphasis on fancy performance demos. For example, juggling before walking, or robots that change their own shape, even if they can't do very much in any particular shape. And my impression is that this resembles AI's early focus on chess and calculus problems and IQ tests. Just because some physical behavior is tricky for humans to do doesn't mean it's necessarily tricky for robots, or that its successful performance requires or implies any deep progress in robotics. And one has to ask, has all this focus on citation counts and benchmarks and fancy demos led to dramatic advances in the capabilities of real robots to function successfully, deftly, and smoothly in unstructured environments for the benefit of humanity? I think not. Thank you.
Thank you very much, Stuart, for these well thought out opening arguments. And now we move to the against team. First will be arguing Professor David Hsu.
Right. I think I will start with an anecdote. And a few days ago, during dinner time, and then my son was making a comment, and well, in fact, he was whining, and that's his whining. I mean, English essay grading is so subjective. I'm pretty sure that he's not talking about his English essay, he's talking about his teacher. So I comforted him and assured him everything will be all right. Right. So, but that helped me to think about what we are talking about today. And in science and engineering, generally numbers are good, but at the same time, English essay is not a number. So is our long-term needs of the field better served by the numbers, or is our long-term need more like an English essay? And I do think that metric doesn't have to be incompatible with our long-term needs. So what do we need in the long term for our field? I tend to think there are two things that are important. One is clearly identified objectives for the community. And the other one is measures of success that offer equal opportunities to all, and more importantly, are transparent to all. Right? So I tend to think that a metric, numbers, is a summary of an underlying state of affairs. there is an established rules that operate them. Certain things we can do, other things we cannot do, or we should not do. And that should be clear to all. And also that it will be good to keep in mind that what is being summarized, what's the context of summarizing things, and not try to go too far beyond that. Right? Now, I share a lot of concerns with the things that Stuart just mentioned. I think you can cite lots of examples of those metrics that are problematic. But I tend to think that in each of instance of them, it's the particular metric itself that's a problem, and the people who misuse them that's a problem, rather than the metric in themselves. Let me put it this way: people are lazy. So here are, and they tend to misuse the metrics. And here I'll give my examples, and I also want to say, again, I want to mention this point, it's that these metrics are being misused or used for unintended purpose rather than the metric in themselves, right? So the more very common example would be numbers in the news media, right? So if you read a newspaper article and the title contains a number, that number probably is generally doesn't say what it actually says, because it's never intended to. I mean, the numbers in the newspaper article titles intend to catch eyeballs. Is not intended to inform. And so I think, and we should be all aware of that. And then the other way is, of course, university administrators and including my own university, and I've heard this one before, right? If there is a number, a bigger number is better than a smaller number. I'm not sure about that one, but this is actually very true. I mean, it comes from one of our university administrators, but there's nothing special. I'm not saying our university is necessarily any worse than any other university. I think it's the same thing can equally happen from a minister of education in another country. I mean, it's just that way it is. That we oversimplify the numbers. We tend to forget what it actually says in the context of which that we're supposed to use them. And instead of whining about all the other people, which I think that we ourselves has problem as well, right? So, and I think in certain segments of our field these days that we have this obsession with outperform the state of the art. The problem is not the art. The problem is the state. What state is it? If we must insist that a robot controller must outperform in, let's say, OpenAI Gym, right? Now, what does it actually tell us? I mean, suppose it indeed happened. What does it tell us? Does that say that the robot controller, that controller will do well on the real robot in the physical world, or does it actually say that it actually outperforms in the gym, in the simulator? I think that's the question that we need to understand. What are we talking about? What is the state we are trying to summarizing, and which state of the art are we trying to outperform? That's all from me. Thank you.
Thank you so much, David, for these thoughtful ideas against the statement we've been asked to debate. Now I invite our second debater from the 4 team, Professor Elizabeth Croft, to give her opening arguments.
Thank you very much. Well, I will start by sort of summarizing what I've heard from my learned colleague, and that they've argued into a sense that metrics are driving innovation, and that what we really need are clearly identified objectives, that the measures of success that are equal and objective. But the problem is with a measurement, it all depends where you take the measurement from, right? If I measure from well below my feet, I could be 6 feet tall, and that would be awesome, right? But if I measure from my neck up, so it all depends on where you put that starting block. It would also be fantastic if the world was black and white and we could measure things in absolutes. But the fact is, as my learned colleague has said, people misuse metrics. And so the question is, have we actually thought through them? And I would argue it's far too easy to make mistakes with metrics. The metrics cause us to focus quite narrowly and present undesirable outcomes, because what happens is the metric becomes the goal. They become the reason to accept or reject ideas, papers, and projects, and also people, because they do not measure up to a particular number. This is actually counter to the role of research endeavor, which is to expand knowledge and to create new ideas for the benefit of society. In fact, the mission of the Robotics and Automation Society is to foster the development and facilitate the exchange of new scientific and technological knowledge in robotics and automation that benefits members, the profession, and humanity. Our goals are not KPIs. As researchers, we aim to benefit society, and individual metrics will never get us there. The drive for personal metrics leads to the exclusion of researchers, and we've already discussed why this is not how we should promote people, and especially from people from non-traditional fields who will be excluded from consideration if we do it just based on the numbers of papers that they published in our area. The problem is that the metric is not the goal. It is only a proxy, and often a poor proxy for a desirable state. As Stephen Kerr so well described in his oft-quoted 1975 paper on the folly of rewarding A while hoping for B, perverse outcomes of poorly designed metrics abound. The fact is that most metrics set in robotics, and more broadly in that fact, have not been well enough considered with respect to the long-term benefits of the field. And what are the long-term benefits of the field? Structured robotics and automation has actually come a long way. It is quite mature. Improvements occur, but they are only incremental. The breakthrough areas are always at the intersections of disciplines where the diversity of ideas and backgrounds and a healthy disrespect for the rules should reign. This is our past as roboticists. This is where we came from, and this must be our future. The 2018 paper on the 10 science robotics grand challenges listed new materials, bio-inspiration, new power technologies, swarms, extreme environments, fundamental AI, brain-computer interfaces, social interaction, medicine, ethics, and security. We will not make an impact on these grand challenges by individual metrics, either on the things that we do or how we measure the things that we do. My field, human-robot interaction, depends on collaboration with people from anthropology, sociology, psychology, computer science, engineering, health professions, ergonomics, physiology, and the list goes on. In such a field, individual metrics will fail to capture the diversity of thought, of ideas, of contribution, and creativity necessary for the broader success of the team, for the broader success of our field. We like metrics because, like my colleague's son, they make us feel secure. There's no ambiguity. It allows us to feel grounded, to give us a false sense of security and progress. But we must be more brave. We must eschew incrementalism and choose the excitement, the opportunity of open-ended questions, collaborations, and discovery. Thank you very much.
Thank you, Elizabeth, for these inspiring opening arguments. We now turn to our last of the four debaters to hear his opening arguments against our statement, and that is Matthew Johnson-Roberson. Please.
Thank you. Well, I think we're lucky on our side because I feel like the four side is arguing for what we want, which is that individual metrics are great. We just need better ones. And so certainly we would not disagree that, better metrics or determining better metrics would help us excel. But certainly throwing away all metrics, I think, would be very problematic. And moving away from individual metrics, I think, could be even more problematic for a handful of reasons. So yeah, the metrics are bad. Sure, let's, as scientists, choose better metrics and assess if they are getting outcomes that we want and modify them to improve those outcomes. But throwing away individual metrics seems like not the answer to that question of the individual metrics that we have right now aren't working for the outcomes that we want. If you think about individual metrics, right, the basis for many of the sort of Western economies that most of these research universities are based in, and say what you want negatively or positively about capitalism, but it is a system that is exported across the world and is generating some level of human well-being in some places. But if you think about those individual metrics, right, if the game is rigged, I would argue, then it is at least a system that junior researchers or people earlier in their field understand and have been designing and practicing to play. And so I think it's all well and good to say that we're going to throw these away, but who does that really benefit? I think that benefits people that are already in power, because then they're in a position to say, well, we care about this or we care about that, but we don't really care about these metrics that we set up that allowed us to become successful. We care about more subjective things, right? So contributions to human knowledge. I mean, that sounds great. I'm all for contributions of human knowledge, but isn't it the definition of elitism to say that we're going to give power to people, or the people that are already in power are going to be able to decide that and decide it in a way that's going to be opaque to people that are trying to come up or trying to get into those systems, right? At least as somebody younger, I can look and say, oh, there are grants, there are papers, there are these individual things that I can strive to get, and then I'll have a hope of becoming promoted or getting hired or being more successful. If we remove those and we say, well, we're not going to have individual metrics, it's going to be group metrics. Well, who does that benefit? That benefits the most famous person in the group that you're working, right? The work's going to be attributed to them. It also limits the ability to move centers, right? If I want to move from one place to another, how do I demonstrate that the work that I did there is attributable to me and not to everyone that happened to be there, or to the institution, or to the name? It gives you the ability to compare candidates and to assess and promote them. And so these ideas around, improving the state of the art, around publishing things that are novel, around publishing in things that tend to have high impact factors or high citation rights. Yeah, sure, maybe these aren't the best metrics in the world, but there's certainly individual metrics that motivate us. And so if we have these closed shops, particularly in things that are, again, opaque to everyone, like tenure and promotion, it is much, much easier. I can sleep much, much better knowing that at the very least, I can put together a case that is not going to be dependent on who's in the room, but could be accessed by anybody using these numbers that have been kind of laid out, or these metrics against benchmarks or whatever. And particularly for people coming from countries or institutions that were not part of this sort of elite, the rise of China as a research powerhouse in the last 10 or 15 years has been driven, right, not because previous holders of power were really keen to hand off that to a new country. It is that we set out a set of rules, and Chinese research institutions and Chinese companies were able to look at that and say, hey, we can really do well on these benchmarks. We can do well on these citation counts. We can do well on these H indices. And so I see it as inherently, in some ways, a democratization of the field to set out these rules and then let anybody play. And so I think eliminating them could lead us down a really dangerous path of, again, a very small number of people that hold power deciding what's next. And then to look at sort of, views from the economy and other things, right? We're here on Zoom. Whoever made this is now a billionaire. You think about all the people from Facebook and Amazon that have, given us all these lovely products. As a personal aside, I think we should eat the rich. But who cares? The idea is that this system is one that is producing all these outcomes that we seem to be happy with, at least in the short term. And all of those, right, the whole venture capital system and that whole model is based on this idea that you yourself can benefit immensely, perhaps too immensely, but immensely from the things that you contribute. So all these things to me seem to point to the fact that we really need to think about how we can use individual metrics and make them better. That's it. Thanks.
Thank you, Matthew, and thank you all four of our debaters for sharing these opening arguments. Now we move into a 20-minute discussion. There are some questions coming in on Slido, and I want to launch one of them out to the panel for discussion. It actually picks up on something Matthew was just speaking about. The audience member noted that there's a contradiction that Professor Croft was suggesting that metrics reduce access, and Professor Su was suggesting that metrics improve access, and this was also coming up in Matthew's conversation. So I want you all to just discuss that, pick up that topic a little bit more, like which is true. Are metrics helping broaden access to our field, helping people enter, or are they harming the broadening of our field, access to our field. And please, whoever would like to respond.
Yeah, I'll take that
Stuart.
one. I found that the idea that citation counts, for example, are democratizing and facilitate access and entry, particularly for people from, let's say, not well-known institutions or countries that don't have very well-established communities. I find that a bit counterintuitive, actually, because there's clearly a network effect in citation counts, right? If I want to cite the important papers on a given topic that I'm working on, how do I find them? I go to Google Scholar and I type in the topic. What does Google Scholar give me? The papers with the higher citation counts. And so I cite them. And so they get still higher citation counts. And so you very quickly get papers that are, by citation counts, canonical, but it could be almost entirely random. And often the most cited paper is not the paper that really introduced the idea. And there's another weird effect, which is that if you have a really great idea, people stop citing you, right? So Stephen Cook, who invented NP completeness and modern complexity theory, has a very low citation count. It's about 22,000. So it's like, quantitatively, that's half as many citations for Stephen Cook as there are to my textbook. And I can tell you, Stephen Cook's contribution is far greater than mine. And why is that? Well, because his idea is so important that no one needs to cite him. When they put NP completeness or NP hard, they don't cite his name because everyone knows what it means. We don't cite the inventor of addition and multiplication when we use them in our papers either. And so I think citation counts is a really bizarre and also easily gamed metric. And it's easier to game for people who are part of a well-established network already. And so I actually think it makes it more difficult for people to come into a field because it also sort of suppresses the content of ideas in that way.
Thank you, Stuart. This argument about positive feedback. Please, Elizabeth, continue.
Yeah, I would also like to add that the metrics just make us lazy, right? If I'm going to promote people based on metrics, I don't actually even need to show up. I have a spreadsheet, I'm done. But actually what I want to do is read their papers. I want to find out, I want to talk to them. I want to hear their ideas. I want to find out how they have had an impact that, where they changed some other people's ideas. That's not going to come from a citation metric or whether they made something incrementally faster or whether, they could recognize X% more images or whatever it is. I want to know what the idea is, and that takes work. It's good work. I learn a lot from doing that work. And I think we all learn a lot when we look past the metrics and find out what's in there behind in the person and their ideas.
Thank you, Elizabeth. David or Matthew, would you like to respond?
Let me try this one. So I think the concern here is really about the citation count. Let's just make sure we understand what citation count is. It is a measure of popularity of work. It is not a measure of the depth of the intellectual contribution of the work. Therefore, anyone who confuses the two, then that will be a problem, isn't it? When we promote and tenure faculty members, we evaluate their intellectual contributions. We are probably that's less about the popularity of a particular piece of work. So that's what I have been emphasizing so far, that when we use a metric, we better keep in mind what this number summarizes and what is intended to use it for. If we actually want to, let's say, vote for the most popular work of a particular field or subfield, we might as well just use citation count. There's no problem with that, right? That's my point number one. My point number two is, I think that for people sitting on the periphery of the community, or maybe these days the world is better connected, much better than before because of the internet and everything. But there is a time, but still in various form that people sitting on the periphery. I mean, a metric at least serves, maybe that is not as an ideal objective. Maybe it is only a proxy, but it still starts as a starting point, isn't it? And before we actually get to understand the deep intellectual contributions, which can only, I think that mostly is nurtured and passed on from person to person when a person does not have that opportunity. And have a metric over there serves as a meaningful proxy starting point.
Thank you, David. Matt, do you want to add anything on this topic? No? All right, I'm going to throw a different question out to the panel, which relates to the things you were just talking about. Okay, if we all agree that these individual metrics, they have some flaws, I ask you, what metrics do you care about? We heard a little bit of like reading papers and quality of ideas, but how do I get at that? What metrics do you use to evaluate your own personal professional progress? Or do you tell your PhD students, or when you're hiring or promoting? Like, can you just give me a little bit more? And maybe you should keep in mind which team you're on, but like, what are the metrics? If we need to make decisions, like whom to hire, whom to tenure, whom to promote, whom to give an award to, what should we look at? How do we make those decisions? What ideas do you have?
I have to go and say we always start with, talking to people, communication, what we're doing now, sharing ideas. I mean, recommendations actually from other people also are pretty darn people that I trust, that phone a friend, because those are the kind of things that, you can find out something that's more than a number. I also think that one of the things I'm always looking for, to be honest, is somebody who's different. Because somebody who is different in the way that they think, in where they came from and what their experience is, and they're doing something interesting in robotics, they've pushed harder, they've done more, they have been different and succeeded. And those are the people that I always find have the most interesting, they always surprise you because they've come from somewhere different and they've had a different idea. So if one of my metrics actually is diversity, it's really critically important.
For offering these alternatives to the current metrics. Would anyone else like to speak to metrics that they really value, that they think are worthwhile considering?
I think metrics is the wrong word. If by metric we mean something that can be placed on a linear scale. One of my jobs at Berkeley was to oversee the entire academic personnel process. So I looked at the promotion cases of every single faculty member on the campus, and the appointment cases and so on. Mm-hmm. And there are people who write recommendation letters that talk about metrics of citation counts and H indices and say, well, this H index would place the candidate in the top 3% of so and so, and we just throw that letter away, right? And it means absolutely nothing. All it tells me is that the writer was too lazy to understand what the candidate was doing and explain it. So we always look for what is the idea? What is the contribution to knowledge? Whose mind, as Elizabeth said, whose mind did it change? Who did it enlighten? What impact did it have on the world's understanding of some important topic? And these things cannot be expressed by numbers.
The dimensionality of people, it's very high dimensional space, and we're trying to put people, and running it down to one number is too hard. So you're looking at other forms of evidence, which it sounds like takes more time. Did you? I'm sorry, I interrupted.
It takes more time, and it's the content. It's the content that matters. So Whether it would be citation counts or, numerical progress on a benchmark, if someone writes builds a robot or writes an algorithm that, gets a 2% better result on some benchmark, that conveys no information to me about whether there was an original contribution there at all, right? I suppose it says that, that they're competent engineering implementers, but it does not say that there was a real original idea happening. And I think this is really important. And David's comment about the English essay, I'm sure David didn't mean it this way, but it sounded like David was saying, we should simply rule out English as a thing for the human race because there's no quantitative benchmark of English progress or individual English success. And I think that's making the argument for our side extremely well.
Would our against team like to respond and maybe argue in favor of any metrics we are commonly familiar with or that are here, and what value they have? What is the value? Which ones do you rely on?
I'll jump in on a metric here. Yeah,
Please.
so as flawed as these metrics of popularity and HNCs and all of those are, right, what they get away from is exactly what I'm hearing here, which is, I call my friends up, and everybody who's like me, who thinks the same way as me, who I choose to spend my time in, or at least in the same world as me, what do they think, right? And so it's a closed shop, right? Everybody it's circular. Everybody agrees that this is a contribution to knowledge, and how do new truly innovative ideas break into that, right? If you're working in an area that people, at least in the establishment, aren't into or don't like, what is the metric or what is the means by which those things can break in, right? And I think also, how do you hold people accountable for these decisions if there are no metrics, right? So imagine, let's imagine a hypothetical world where we look at the data and somehow, there's some adversary on the tenure and promotion committee, and every single person that's ever come through with the left hand has been denied tenure. And you look at them and, you look at all their numbers and you look at the metrics, and it's not really clear, like, if there's a lot in common, right? But then you go back and you're able to look at this and you say, okay. And so you go ask that person, well, why didn't they get tenure? And you say, well, they didn't make a contribution to human knowledge. And so, well, what does that mean? And it's like, well, we looked at some letters, we did some things over here, we did this, we did X, we did Y, but it didn't meet the bar, right? And I don't see how you could use a system like that to stop any of the implicit biases or other things that we know are there, to even detect them. Because ultimately you're saying, well, the smart people in power already have the answer here. And we'll just trust that somehow they're not going to apply all the things that have led to the great demographic imbalances we see, particularly if you think about tenure and promotion, right? Who are the full professors, right? They all look the same. And so what are we really going to get out if we keep letting them make the decisions?
Thank you, Matthew. David, anything to add or?
Yeah, let me do a quick response to Stuart's comment about the English essay. And I can assure all of you, English is important, language is important. But that recently there's this thing called the word embedding, and that can turn English into vectors. That has been working quite well as well. So now, once we have word embedding, that's a vector, and then we compress that into a single number. So it's, as I said, it's a number. It's a summary of underlying state of affairs. Not all summaries are same. Some are better than others, right? So since I have been trying to, I have to argue for numbers. So I actually have done some work on a homework on numbers. Now, I will have to say that if the popular numbers, if you look at the Google Scholars and the I-10, which is a number of papers that gets at least 10 citations, that just encourages people to, if you want to game this number, then you should publish barely publishable papers and write as much as possible, right? So that is bad. Now, H-index, which says that X papers with citation at least X. What is that? that encourages mediocrity. If you want to game that number, you look at your mediocre papers and say, how can I improve the quality, next paper improve quality just by epsilon. That will maximize my ascent for H index, right? So if you want me to fudge a number, I will fudge one for you. So this one I think is better than the other two, not to say this one is the best. I would say I will look at the total citation of your top 10 cited papers, or top 5, and whichever threshold you want to pick. That I think will get people to think about how to improve my best work, and on the average will move our if each and every one of us does this, on the average, that will move our field forward, I think.
Thank you, David. I really like this conversation we're having. I want to pick a question that was proposed by Greg Dudek on the Slido, and I'll read it to you. He says, nobody mentioned Goodhart's law, a maxim in management that, if we put it in the language of machine learning, suggests that defined metrics lead to poor generalization in human endeavor, but good performance against the metric itself. And I think this picks up on some of the things that David was just saying, like people will maybe there are some perverse incentives, so and we'll try to game the system, whatever metrics we choose, that there are ways to try to manage towards that, to overfit. Do you agree that we can take this principle from machine learning, Goodhart's law, and bring it into here? Is it worthwhile considering?
Yeah, Goodhart's law is a law that says exactly what Greg says, and I think it's highly relevant here, and it's been observed in many places. And in fact, the paper by Stephen Kerr that Elizabeth cited is another important original source for the same problem. And when we look at numerical rankings for universities, for example, so it's one of my favorite ones, the U.S. News and World Report rankings of universities. So it's a so-called objective metric, right? And how does it work? It calculates, I think, seven different numbers, and then takes a weighted average of those 7 numbers. And you might think they're all very worthy things to pursue, like faculty quality. So when you look in the footnotes of the footnotes, how is faculty quality measured? It's measured by average faculty salary. So a private university that can pay its faculty whatever it wants, whatever its endowment can supply, has necessarily, therefore, a higher faculty quality. Universities like Oxford and Cambridge, which traditionally have paid fairly low salaries. In fact, I think last time I checked, Cambridge insisted on paying all its professors the same, right? So there's no superstar salary system at all at Cambridge. They would lose out on this metric. And of course, so what do you do to raise your ranking as a university? You pay your faculty more, and now you're a better university. The same professors, right? So this happens over and over and over again. Once you set up metrics, you get behavior that optimizes the metric and not the thing that you are hoping for to have.
And then the students are paying higher tuition to get the same.
Right. Another example is, so student satisfaction. How is that measured? By the fraction of the graduating class who gives money. Right now, in many universities, for example, in France, the idea of giving money simply doesn't exist, right? And my kids all went to a French school, and we sweated blood to get the French parents to donate to the school, because that's just not what you do in France. And so this is another ridiculous metric. So how do you raise the quality of student satisfaction? You give all your students $1 so they can give it back to the university when they graduate, right? I mean, this is insane. And if this is a way of ensuring progress in robotics, then I think we're headed for the same kinds of problems. And I would argue
1 minute left in our discussion for everyone.
Yeah.
So
I would really argue, I think benchmarks in their early stages can help people to focus, as long as they're well-designed, important problems, can help people to focus can lead to sharing, they often incorporate standards, which I think are really important. But I think they should be abandoned as soon as people start competing on small incremental progress and sort of claiming that my paper should be published because I got a 1.1% increase on this metric. And then you should stop and say, okay, time for a new benchmark.
Would anyone else like to add any comments on this Goodhart's law and metrics?
The last point that I would like to make is the problem that the metrics embed bias. They bake it in, because whatever is set as that metric, it comes from the people that were there. And as long as we continue to propagate that metric, it will always benefit the in-group. The out-group will always have a disadvantage. And so it's only by breaking down the metrics that we actually democratize the opportunity for science.
Yeah, so you're saying the metrics themselves become self-perpetuating because they're chosen by those in power, and then we're all, and that's where maybe what you were talking about, looking for a difference, looking for a novelty, looking for, people
the
who
next
bring
opportunity.
unique perspectives. Yeah, looking for the next big thing. But one could also argue maybe we run a risk of hiring people who aren't qualified, who don't know anything, who can't do anything. I mean, I'm just wondering, I'm being a bit of devil's advocate.
Absolutely. And then it comes down to having a diverse group of people on your panel that is interviewing, the perspectives. Because if you get a smart group of diverse people together who are willing to debate the benefits and challenges of you will be able to come up. But it does require people who are invested in the benefits of the group, of the university, of the department. You have to have people that are willing to take the time to go to the seminars, to meet with the candidate, to read their papers, to learn about them. And you have to, again, I can't repeat enough, diversity breaks down the dangers that metrics put before us.
All right, thank you everyone for this discussion, and to the audience members who've been suggesting questions. I'm sorry I haven't been able to get to every one of them, but we hit many of them. Now we move into our closing remarks, where each of our four debaters has about 2.5 minutes to summarize, to restate their position with whatever nuances they want. I'm going to reread our statement again for everyone to consider freshly. Individual success metrics prevalent in robotics create perverse incentives that harm the long-term needs of our field. And Stuart, you've been arguing in favor. Do you want to summarize your position?
So I think to summarize my position, I would say that the primary value of benchmarks, which is one of the success metrics, is in promoting standards and participation and sharing. As I just said, they lose their value once numerical performance becomes the primary topic of interest, as it has, I think, in many of the ongoing benchmark competitions that are happening in AI and robotics. I think Matthew's point about the structure of our field potentially excluding people from less well-endowed universities or less technologically endowed countries and outgroups. I think that's a really important point. I think it's an open question as to whether these numerical metrics make that problem better or worse. My sense is actually that it makes that problem worse, because as I said in my opening remarks, it's very hard to get a new idea published in a metric-driven field without doing all of the work and having all of the machinery and the engineering capability to do what everybody else has done with their machinery and their engineering capability, and then some more on top of that with the benefit of your new idea. It ought to be possible simply to publish the new idea with some evidence that it's a good idea, without having to rebuild the entire, let's say it's ImageNet, the entire, GPU computing pipeline and the vast array of techniques that are already in place to achieve the performance levels that are being achieved, and then have to do, add your new idea onto that to show that it's better. Surely you should be able to just publish the idea with sufficient evidence that it's actually a good idea. And so I would argue that these types of benchmarks actually work against the entry of new people into the field.
Thank you, Stuart.
And I think David made the case for us best of all by saying that English should be ruled out.
Well, let's let David make his closing remarks against this statement that we've all been considering. David?
Sure. If we cannot measure, it will be difficult for us to make progress. At least we wouldn't even know whether we are making progress or not. The problem is usually not the metrics itself, and it is difficult to find. It's not so easy to find the right metrics. Therefore, it is especially important that we pay attention to the process of establishing the metrics. I think the problem comes if one group of people come up with the metrics and the other group of people are subject to the metrics. That becomes a problem. Therefore, what we should do is to involve the broader community and getting all of us to think hard about what is the right metrics. And the metrics helps us to establish our objectives, our field, to be transparent to all, to force us to articulate and provide the evidence for such objectives and to make it debatable and transparent to all. And by doing that, I think we can work towards a common objective and advance the field.
Thank you, David. Now we return to our 4 team and hear Professor Croft's closing remarks.
I am in furious agreement with Stuart that what we need is benchmarks, not metrics. We need to, because quite frankly, we just need to get to the benchmark, right? If we can do the whatever it is, that's great. And then we can open up to creativity. There's this myth that metrics are somehow fair. Metrics are not fair or objective. They are inherently biased to the group that has developed the metric. And they continue to focus us on the metric as the goal, as opposed to what our true objectives are. So we just really need to step back from metrics and step forward to having benchmarks that tell us, well, where we are and what we're doing, so that we can open up to the opportunities to bring in the other fields, the diversity, the other kinds of thinking that allow the creativity and the opportunity of our field to really have an impact for the benefit of society.
Thank you, Elizabeth. And now we move to our final closing remarks from Professor Matthew Johnson-Roberson, arguing against this statement. Matthew?
Thanks. Yeah, you can point out these sort of problems with, like, let's take U.S. News and World Report, right? Okay, so there's these metrics that can be gamed, they're bad, but if you're trying to distinguish between the number 1 and the number 2 or number 3 school, yeah, people are jockeying for position, but if you look at the rankings and you look at the top 10 schools and you look at the bottom 10 schools in those rankings, those general trends are going to reflect the way that students make decisions, the way that research money is doled out. And not to say that schools on the bottom don't make contributions to human knowledge, but if you're looking for where the places where the things that we've set out as what our goals are happen, at least in an R1 research context more often, yeah, like those rankings sort of work. And it's the same with H indices. Like, I don't think that, somebody that's 1 higher or 2 higher than somebody else has made a much greater contribution to human knowledge, and we can put people on a number line and say that this person's marginally better than this person. But if someone has 0 citations, I think I can be pretty confident that their impact on the field has been pretty minimal, literally no one has chosen to say that this work is worthy of citation, and they're not going to build off it. And so, yeah, at the marginal cases, maybe it doesn't work, but I think that these are problems with improving the metrics and not comparing, things that are really close to each other, but not fundamental problems with individual metrics. And moreover, if we think about trying to, let people from out groups or whatever participate, think about what changes we're doing around standardized testing. If I'm a kid from a poor high school that has no advanced placement classes, no classes that are beyond basic high school education, and I'm not able to learn and practice and get a perfect score on the SAT, how do I distinguish myself from everybody else who has much greater opportunities, much greater chances to go to, do various charity work and all these other things, right? If you provide something that somebody can look at and attempt to game, or in the worst case, or, measure up to, practice against, right? I do think you give people the opportunity to break in that would not otherwise have access, because otherwise I think it is a realm of elitism to allow us only to care about people that are already in the world that we're describing without setting the rules out in a way that they can clearly understand. Thanks.
Thank you, Matthew. I find compelling arguments on both sides of this debate, which is really delightful. Now that we're finished with our closing remarks, I'd like to announce the post-debate audience poll and invite everyone who's watching the live stream to go to this Slido link that's shown on the screen and vote for or against this statement that individual success metrics prevalent in robotics create perverse incentives that harm the long-term needs of the field. I'm really curious to see how many of you we've convinced in which direction. The poll is going to be open for the next 5 minutes. And this is where now we can take a deep breath as the 5 people on the panel, and the 4 of you have done an admirable job of arguing for and against. And now you can set that opinion that you were agreed to take on aside, and maybe we can have a little bit more conversation about your true opinions, if you really believe the things you've been saying, or if the other debaters have made some good points that have persuaded you, if you want to compliment each other on any of the points. So here, I open it up for a discussion among the 4 debaters. We have 20 minutes.
Metrics are stupid. They're killing our field. It's the worst.
I think I want to congratulate myself. I curse KPI every day, and I think I did a fantastic job as a debater.
Agreed. Metrics are the worst.
I do want to congratulate Matthew, because he was just, hammering hard, and it was really impressive the way that you were working hard at that. It was congratulations.
Matthew, did you end up arguing in favor of using SATs for college admission?
No, so I think we should actually get rid of them. But I do think that one of the only compelling arguments that I heard against that, and somebody made the point to me in one of our meetings, it was the GREs for us, but look, how are kids without access going to be able to distinguish themselves? Which I think is a very valid point. The points that lots of people were making, I think we have, I don't think the GREs are assessing the thing we want to assess. And so ability to game the GREs, I don't think is going to substantively improve access to whatever groups we believe are disenfranchised. So I am still pushing for the GRE removal. So, that's me though.
Yeah, we removed GREs, and what we found was that we admitted less than half as many students from small universities.
Interesting.
Because they don't have access to research,
right.
And so there was nothing to distinguish them. We didn't.
Just to follow up on Matthew's point, I think I want to give this example of China's national matriculation exam. That's pretty much the only chance for the poor kids in the countryside to climb up on a social echelon, and that is good. Compared with all the kids in the cities with tutoring, with tons of resources. The kids in the countryside, they have virtually nothing. They can study 16 hours, while the kids in the cities maybe 4. But matriculation exam is the same for all.
Yeah, this debate actually resonates with me too. Matthew, do you want to respond?
Oh, no, sorry. Please go ahead.
No, I was just going to say, I run a big PhD program here at the Max Planck Institute for Intelligent Systems, and we don't ask for GREs or any standardized exams, partially because there's a cost. You have to pay, and we had applicants. We don't even charge to apply to our program. It's free because we really wanted to have a very low barrier to entry. But then on the other side, Matthew, your point resonated with me. I mean, I'm a woman. There aren't that many women in engineering and technical fields, and I always felt like if I could get a high GPA, get a good score on the SAT, then no one could deny that I deserved to be here. Of course, I had many privileges that I was able to lean on. I had parents who were deeply committed to education, but I still worked my butt off and then felt like, okay, at least I have some evidence. Like when a tour group walks into the lab where I was working as a PhD student at Stanford and laughs and guesses I'm the secretary and not one of the PhD students because, wow, are there women grad students here? Like, I can be like, well, yeah, you can laugh, but like, I actually deserve to be here. Like I had whatever SAT scores, GRE scores. I've published these papers. I've been cited 5 times or however many times I'd been cited at the time. Someone cited me, you know, I'm not nothing. I could try to claim these metrics. So there's both sides of the coin. Would other people like to respond?
Yeah, you see, in Canada, there isn't the same kind of SAT thing. It's really, but in Australia, they have something that's very, very similar. And it just drives the weirdest behavior. So what happens is kids, to get these super high scores, they pick particular subjects that they take only because they think they can game the system to get that high score. So what you see is kids stopping taking calculus and stopping taking physics, especially girls, because they're thinking, well, if I take these subjects over here, if I take French or something like that, I can get this high. And it's girls and boys. So we just see the weirdest behavior going on because people are tiny. So it's just this perverse thing that happens. And it all becomes about this one stupid ATAR score. And so I just, I think that, what we actually have to do is just, it's time for slow food around education, taking the time to really, invest in making sure kids have experiences to do this, investing in public education. It's the best thing that any country can ever do to improve the quality of life for their population. And that really, it takes effort, but it won't be I get the whole thing India is the same way, right? What David was mentioning, kids, their golden ticket out is that score to get into an IIT, right? Because if you have that, that is the way out of poverty. But I think the thing is that it works kind of at one end, but then it just does not work. When you get to a certain point, it just doesn't work anymore. And I think that's what Matthew was saying is, maybe it differentiates from the very top and the very bottom, but there's a lot of kids in the lower middle class that we're not going to reach because they don't have that opportunity, because we're measuring on a metric that they're not going to get to. And they would be fantastic scientists and engineers. We have to find a different way to get them.
Yeah, I want to bring this closer to robotics, and think, does anyone want to speak a little bit more about what role you think individual success metrics or evidence they're prevalent in robotics, or that we should introduce? Any ideas for the future to avoid creating these perverse incentives that might harm the long-term needs of our field? Do we have any proposals, like positive steps forward or reiteration of things you've heard here that you believe in?
Just a thing that I think is important is to look at computer vision and the evolution of computer vision, because I feel like that, to me at least, feels like one of the closest fields that has gone through a transformation over, my short professional career. And I think I feel like they are 10, maybe a little bit, maybe 15 years ahead of where robotics is in terms of the evolution of the maturity of the field and the success and ability to kind of appeal to mainstream whatever industry and society, but I think that it is, the power of standardized data sets and the ability to operate on those has been, I think, one of the big drivers of increased participation from other countries, right? So I don't think we would see as large an impact of China if Vision didn't have these things that you can really crank on and grind on without having to have all of the resources and sort of infrastructure that historically important universities have had. But I don't think we want to go that. I don't want to go that route, right? So I would like to try to shift the field in a different direction so that we emphasize outcomes that are not on that axis, because I don't think that there's a good parallel for robotics in terms of its generalizability or whatever that you can optimize on one data set, and the real world is just not like that. And I think that is a different problem than the problem that Google or Amazon or whatever wants to solve. And if you need something to work in the real world, I think having some way of rewarding taking the effort to do experiments in really highly chaotic environments that are real is something that we should be pushing. And that is, I think, antithetical to the data set optimization publication machine.
Well, I mean, all of us have a bit of power in this. Like, we all review papers, right? And we or co-chair conferences or serve as associate editors in journals or serve on thesis committees, examine PhD students, guide our own students and postdocs, write letters, help promote people. And so are these things we should be keeping in mind? Maybe I heard several times in the debate, it's sort of lazy just to Google Scholar someone and say, oh, their H-index, their number of citations, or and like say, oh, they're inherently better than me or worse than me or better than candidate XYZ. But how can we, that doesn't come up when we're evaluating individual papers, right? Like we read the paper and we try to get excited or see if we can get excited about the ideas and the methods. Do we trust this? Is it persuasive? Does this get me excited about? No, you don't think so, Stuart? What would you say?
Well, I mean, I think we look at the table where you put the boldface for the number that's higher than the other ones in the other columns, and if this technique has lots of boldface numbers, compared to the other techniques on the benchmark, then it's better, and then we accept the paper. And I looking at what's happening in computer vision, I think it's interesting. I think the cracks are actually beginning to show. There's a paper from Dave Gifford's lab showing that the algorithms have actually not learned to recognize the objects at all. In fact, the algorithm that's supposed to be, where it's trying to recognize what type of dog it's looking at, it's just looking at the carpet to figure out what type of dog this is, and recognizes parachutes by basically counting the amount of sky in the picture. So it's back to what those old anecdotes from the 1960s about Russian tanks, incredibly fragile. And I was looking at it. I went to a talk by Nicholas Ayash, and his group showed that if you rotate the pictures of skin cancer by 45 degrees, the algorithm changes its mind about whether you have cancer. And so on. So in fact, what you've created by this overfitting, I mean, it's sort of a field-wise overfitting, but you've actually created extremely fragile algorithms, and you've confused success on the metric with success at computer vision. The other thing that's happened is that there aren't any ideas about vision anymore, right? If you say, well, what are the ideas there? Oh, well, you should put this layer in front of this layer, or you should add these extra layers, or you should, have this, ResNet bypass or whatever. They're not ideas about vision anymore. They're just, so we did this kind of recipe to make our network, and it gave a better number, right? And that we've lost computer vision as a field, if you ask me.
I was struck by something as you were just speaking, Stuart. You were really talking about how metrics drove a field towards almost like trivial overfitting. And then now we've been talking about here, do those metrics at a broader level about people, not about individual algorithms, but we're talking about the system we're all working in as people over the scope of years, and are people overfitting and like trying to game their Google Scholar. I read a horrifying article recently about networks of reviewers defeating double-blind review and like sharing titles of papers and all like even threatening other reviewers to get these papers in. Clearly, we would all agree those are perverse incentives or citation rings or
journals saying we're not going to accept your paper unless you cite other papers in this journal so we can get a higher impact factor.
Yes, or I've read articles about editors forcing people to cite them, the editor, and clearly these are gone wrong. It's easy to recognize, but that maybe when it comes back to individuals, it's a little trickier. Figure out how do we evaluate. But we have about 6 minutes left in our discussion. At some point, we're going to get to see the results of the poll, but I want to hear maybe a little bit more from the panel. Any other closing thoughts in our debrief that you want to make sure each other and the audience hear?
I think one of the things that can help us is by, getting the problem with things like computer vision and things like simulation is we can build these nice, neat little simulation worlds, and they are great, and it's wonderful, and it's fast. They're prototypes, but we actually have to get back to doing real world experiments with really random things called people that do weird things when they interact with robots. And we actually
people are such big problems. Go ahead.
Oh,
they're so surprising.
Pain in the ass, actually.
Agreed.
But they're fantastic because they break all your experiments. And so, but actually, the other thing I think we need to do is kind of come back and spend a lot of time thinking about how we are setting up experiments and different methodologies for setting up experiments. We really go as roboticists and scientists really much into the scientific method. I have these control conditions, and I have these things that I'm going to change. And there are other fields like anthropology and sociology that do observational studies and that do, these sort of much more studies based on looking how behaviors occur. And I think that introduces really interesting and new ideas. And those kind of narrative, I still think, yes, we do need to do the really controlled experiments. I'm not saying that we don't do those, but if we can start to look at other ways of doing our science that are not so about, do we measure all these different conditions, we will start to introduce back into the questions that we ask and the problems that we solve more interesting problems.
Thanks. Would anyone else like to share some final comments in the debrief?
I'll just say one thing is that I think, the writings on the wall for universities, they have latched on to US News and World Report, to H indices, to X to Y to Z. They would like to quantitatively assess their faculty, their graduate students, their undergrads, everyone. So I think it behooves us to think about how do we make those things reflect the actual values that we have? How do we make them closer to the ideals that we hold? Because I think we are going to get back into a corner that if we don't present something better, they're going to use the ones that we know to be flawed and bad, simply because academic administrators are lazy, as are everyone else in the world.
Oh, we're limited in time. Hold on, I think several of us are administrators here.
To all the academic administrators in the house.
All right, so here's the solution, right? The faculty have to take power, and this is what happened at Berkeley. The administration has very little role in faculty advancement promotion cases. These are committees of peers, that your fellow faculty members are judging the case to make sure that you're being treated fairly and that you're, to judge how good a job you've done, and not the academic administration side.
I
we
think
call it shared governance, but basically on academic personnel, it's the faculty who decide, not the administration. So you need to strike back against the evil empire.
I want to add over here that I think there's a cultural dimension to this. I think it is true that at Berkeley, maybe many other universities in US, Canada, maybe Australia, what you said is entirely true, but this is not true in some other parts of the world. And it's not entirely a matter of peer review. Administration can have substantial influence on this process. So I would tend to think that the metric is imposed on us. It cannot completely get rid of it. It's better for the community to work on it, to make it better. As I said, not all metrics are the same. Some are better than the others, and we participate in the process, and we can improve it and make it better, closer to our ideals. And I think that the very fact that we have a statement saying that this particular metric is perverse, that means that we have a thought process that helped us to debug it, to say there's something wrong with it. And we understand what's wrong with it and try to improve it. And maybe that's not the best, but probably maybe it could be the second best we can live with.
Thank you, David. I think it's a good time to close our discussion, and I consider this an immensely successful debate, and I invite the organizers to show us the results of the poll. Now, actually, I think we've done a wonderful job debating both sides of this, and we're just going to look through what came out of our audience poll. So before the debate started, we had 36 people vote, and 73% of them agreed with this statement that individual success metrics prevalent in robotics create perverse incentives that harm the long-term needs of the field. We had 8% against and only 19% undecided. And actually, it shifted from there towards the against. So I think David and Matthew won some hearts and minds. And we had afterwards only 61% of people agreeing, 16% disagreeing, and 23% in the middle undecided. So, and that was with 43 votes, so a pretty similar sample size. So with that, I want to thank again all of our debaters for their wonderful contributions. It's clear you all prepared and thought deeply about this and went along with this mechanism of choosing or being assigned a side and arguing a side and sticking to it, even if it doesn't completely align. And I think we made some productive, we had some productive discussions and maybe some good ideas. I found it very interesting, and we'll continue reflecting on this. So thanks again, all of you. And until the next debate, take care. Bye.
All right. That was an excellent debate. Thank you everyone in the audience for joining us. And thank you to Professors Elizabeth Croft, Stuart Russell, David Su, and Matthew Johnson-Roberson for an exceptionally engaging and thought-provoking debate. Also, many thanks to Professor Katherine Kuchenbecker for an excellent moderation of the debate. And we will now take a 30-minute break. We will be back at 11 a.m. Eastern Time. And finally, before we go, if you're interested in being part of the debate of the organizing committee for the next year's debates, we encourage you to send an email at roboticsdebates@gmail.com. Thanks, everyone.